Good afternoon, my YouTube viewers. It is Crystal here, and I wanted to make another video because I made a video this morning on the fact that I got my very first silver medal with Kaggle, and so I thought it was a good time for me to go ahead and make a video on another competition that I entered. The competition was with Kaggle, and it was a community competition, and the title of it was Catch Me If You Can, Alice. And so I worked on this competition around Christmas time, and I did worked on several different models, and I submitted several different models, and this was the highest score that I achieved. And so I couldn't make a video during Christmas because I was at my boyfriend's mother's house. I was using my boyfriend's Chromebook, and the Chromebook would not allow me to make a video on my YouTube account. And as a result of that, I decided to wait until I came back to Reading, the town where I live in. But then I got involved doing some other things, and so I just didn't get around to making the video. But since I made the video this morning on my silver medal, I thought, well, I'll go ahead and make the video on this competition that I entered over Christmas. So I did it on Kaggle's Jupyter Notebook, and the problem statement is predict the probability of a web user by the websites that they visit. So the first thing that we're going to do is we're going to create the Jupyter Notebook in Kaggle, which is what I did. And after we create the Jupyter Notebook in Kaggle, we're going to import the libraries that we're going to use to execute the program. So we're going to import NumPy as NP to create NumPy arrays and perform numerical computations. And then we're going to import pandas as PD to create data frames and undertake data processing. We're going to import OS to go into the operating system and get the files that we're going to need to execute the program. We're going to import sklearn to give us machine learning functionality. We're going to import matplotlib.pyplot as PLT to visualize the data, and we're going to import Seaborn as SNS to statistically visualize the data. So what we want to do now is we want to use OS to retrieve the files used in the competition. And the files that we're going to use are going to be the simple submission, the train session.csv, and the test session.csv. Those are the three files we're going to use. We're going to use pandas to take those CSV files and convert them to data frames. And the data frames that we're going to use are train, test, and submission. And what we want to do is we want to set it up so we can see all of the columns. So we use pandas. We say pd.setOption display.maxColumns. So here is our train data frame, and it has 22 columns of data, with the last column of data being your target. And then so we do train info to see what kind of columns of data we have. And you can see we have a mixture of integers, objects, and floats. And then we check for null values. You can see we've got quite a few null values that we are going to have to do something with before we can do anything with this data. So we're going to have to impute the null values. This is the test file. The test file has 21 columns of data, and the reason why is because it doesn't have a target, because we're going to predict on that. And then we're going to do the submission. The submission has a session ID and a target, and that is what Kaggle is going to want to see when we submit our work. So we're going to analyze target. So we're going to see target equals train target, and then we're going to check value counts on target, and you can see that we have a very big class imbalance. We have 251,264 zeros and 2297 ones. So there's a very big class imbalance. And so I'm using Matplotlib to create a histogram of the target, so you can see that we just have a very small amount of ones. Now we're going to make the data frames numeric. So drop call equals a blank array. For call and train, if train call.dtype equals object, drop call.append call, and then so we print drop call, and then so we are going to drop call from the train and the test site, and then we're going to check the shape of the train and the test site. And so you can see in the train and the test site, we have 12 columns for the train site and 11 columns for the test site. And the next thing we're going to do is, after we've done that on the train num, because that's what we want train num equals the drop columns on the train site, and test num is the drop columns on the test site. And then so now what we're going to do is we're going to drop all of the rows of data that have null values in them. And you can see that we've done that on the train site. And then we check for the test site, and you can see that we've got quite a few null values that we've got to do something with that before we can make predictions. So we're going to have to impute that data. So what we're going to do is we're going to drop the ID column. You don't need the ID column when you're working with pandas, and the reason why is because pandas automatically indexes all of the rows of data, so you don't need the ID column. So we're going to drop that from train num and test num. We're going to impute the null values in test num. So in test num, any value that is a null value, we're just going to fill it with -1. And then you can see we don't have any more null values anymore. Now what we're going to do is we're going to create a heat map for the train num using Seaborn. And so we've got a heat map on train num, and you can see that none of the features or columns of data are highly correlated. So because none of the features or columns of data are highly correlated, we won't have to drop columns of data that have a high correlation. Now we're going to define the dependent and the independent variables. Y equals train num.pop target. So target is your Y variable. X is train num, and X test is test num. And now we're going to use sklearn's train test split function to split the X and the Y variables up into training and validation sets. And then we're going to check the shape of those sets, and we can see the shapes correspond with what we want. Now we're going to define the model, and when we define the model, we're going to use sklearn's extra trees classifier with in estimators is 1000, max depth 5, random state 42, class weight equals balance, and then we're going to fit it. We're going to fit X train and Y train, and then we're going to check the score, and the score is 65. So we're going to predict on the validation set. And so you can see that we've got some ones and zeros on the validation set, and then we're going to check the accuracy of the validation set, and it's 65 is accuracy. We're going to create a confusion matrix, and so when we create the confusion matrix, you can see that you've got a lot of zeros, but 8,001 of the units are ones when they should have been zeros. And you've got 152 ones and 60 zeros where they should have been ones. So we did our best. It's not fantastic, but we did our best. So now we're going to predict on the test set, and we're going to be using predict proba. So predict proba equals model.predict proba x test, pred equals pred proba, and it's going to be all of the rows of data, and it's going to be column number 1. And then we check pred. And then after we do that, what we do is we're going to prepare our submission. Submission target equals pred. We're going to convert the submission to a CSV file, and index is going to be false, which means we're not going to index it. And then we're going to take the submission and we're going to convert it to a data frame, and then this is the data frame that we have. And then after we have prepared our submission, what we're going to do is we're going to submit our work to Kaggle. And when I submitted my work to Kaggle, I had a 65% accuracy, which was similar to the accuracy I had when I trained my model. So it wasn't fantastic, but it's what I got, and it was the best score that I was able to get on the different algorithms that I came up with. So I just thought, well, since I did one video this morning where I was talking about my machine learning expertise, I thought I may as well do this video as well. And so you can see what I did and the methodology that I used to get there. And I will leave a link to the Jupyter Notebook if you want to look at it. So I guess I've completed this video. I've talked about what I wanted to talk about in the Catch Me If You Can competition question. If you like my video, please like and subscribe. Thank you so much for watching my video, and I will be making you a technical video again in the very near future.